Good day and welcome to the second part of Engineering Mechanics tutorial. The topics for this session is Newton's second law of motion with sample problems. Newton's second law of motion states that the acceleration of a body caused by the resultant force is directly proportional to the magnitude of the resultant in the same direction as the resultant force and inversely proportional to the mass. From the definition itself, we could derive the equation A is equal to F over m, where A is the acceleration, F is the resultant force in Newton, and m is the mass of the body in kilogram. Take note that the acceleration is the same direction as the resultant. This is another equation on how we can get the mass. M is equal to W over G, where M is the mass of the body in kilogram, W is the weight of the body in Newton, and G is the force due to gravity equal to 9.8066 meter per second square. Take note that 1 Newton is equivalent to 1 kilogram meter per second square. So this is an example problem. The weight of a person in an elevator at rest is 550 Newton, where G is equal to 10 meter per second square. When the elevator moves upward, the tension in the cord is 800 Newton. We must determine its acceleration. So here are the steps on how we could find the answer from the given problem. So first and foremost, we must get the given W, which is 550 Newton, the G with 10 meter per second square, and T with 800 Newton. The required that is must to find is the acceleration of the elevator as it moves upward. So here, in this right portion of the slide, we could see the illustration of the whole problem. So the next step is to get the formula for acceleration. Acceleration is equal to resultant force over the mass. To get the resultant force, we must subtract the tension and the weight. And in order to get the mass, we must divide the weight over the gravity. By simply substituting the given earlier, 800 minus 550 Newton all over 550 Newton divided by 10 meter per second square, we can get an acceleration of 4.55 meter per second square. So next problem is two blocks are connected by a cord running over a frictionless pulley. The mass of a block A is 6 kg and block B is 2 kg. Ignoring the mass of the cord, determine the tension in cords A and B if G is equal to 10 meter per second square. So, the given in mass A is equal to 6 kg, mass B is equal to 2 kg, and G, which is the gravity, is equal to 10 meter per second square. The required in this problem is to get the tension force in cords A and B. In this right side of the slide, we can see the illustration about the problem. So the solution, we must get the formula. The summation of the resultant force is equal to mass multiplied with acceleration. we can get the summation of the resultant force by this equation. Weight A minus the weight B is equal to mass A minus the mass B multiplied with the acceleration. Now, solving for weight A and weight B. First, we must get the formula of the weight. Weight is equal to mass multiplied with gram. Now, by substituting the given of weight A is equal to mass A multiplied with the gravity, 6 kilograms multiplied with 10 meter per second squared is now equal to 60 kilogram meter per second squared, or 60 Newton. In solving the weight B, same formula. Weight B is equal to mass B multiplied with G, or gravity. Substituting the given 2 kilogram times 10 meter per second squared, we can get 20 kilogram meter per second squared, or 20 Newton. Now, by simply substituting the answer of the weight in the earlier formula, which is this, we can now solve for the acceleration. Weight A minus weight B is equal to mass A minus mass B multiplied with acceleration. By substituting that, we can get 60 minus 20 kilogram meter per second squared is equal to 6 kilograms plus 2 kilogram multiplied with acceleration. Now, acceleration is equal to 40 kilogram meter per second squared. From here, it came up with here, all over divided by 8 kilogram, which is from here, 8 kilogram. Now, the answer would be 5 meter per second squared. So that is the acceleration. So, the solution for finding the tension A as the mass A moves downward. So here is the diagram of the problem number 2. We can formulate a formula from this diagram. Weight A minus tension A is equal to mass A multiplied with acceleration. The question is that why is the weight A positive but the object A here is going downward? The answer is that while the weight goes down, you become more heavier, you will feel more heavier, and if you are going up, like in the object B, it's going up, you will become lighter. So substituting the given from the problem, or given answers from the previous findings, we can get 60 kilogram meter per second squared minus the tension A is equal to 6 kilogram multiplied with 5 meter per second squared. So tension A is equivalent to 30 kilogram meter per second squared, or 30 Newton. So 30 Newton is the final answer for the tension A. So next is, this is the solution for tension B as the mass B moves upward. The formula that we can formulate in this diagram is tension B minus weight B is equal to mass B multiplied with acceleration. Tension B minus 20 kilograms meter per second squared is equal to 2 kilogram multiplied with 5 meter per second squared. Tension B is equal to 2 kilogram we just move 20 kilogram meter per second square to the right side. Then tension P is equal to 2 kilogram times 5 meter per second square plus 20 kilogram meter per second square. And so we can get the answer for tension P, 30 kilogram meter per second square, and also 30 Newton as the final answer for tension P. So that is it. Thank you for watching this tutorial.